Hello, class ninth. So, how are you all? I hope you all are good and you have been studying. I hope so. So we are going to start a new chapter, chapter number 8, motion. Yes. Well, this chapter is very important because if you love science, then you should study this chapter carefully. In this chapter, we will study the equations of motion, yes, and we will see some simple topic like speed, distance, and apart from these we will also study about velocity, displacement, yes. So, and in the beginning, very beginning, we will see different type of motion. Okay, we will not study in detail anything because nothing is given about in detail about the type of motion. Okay, you might have already studied in lower classes about the different type of motion. Yes, and we will see the how to get different kind of equation of motion. We will also study about the graph. Through the graph we will try to find out, so what is motion. Motion is actually, uh, we can say, motion is actually the change from one place to another place, change in position from one place to another place with respect to origin, or you can say origin means reference point, starting point, zero. So changing from the one position to another position. Okay. So I will show you the motion. Well, motion can be uniform also, and motion can be non-uniform also. Okay, we will see lot of examples also. So now first of all, let's talk about the type of motion. Let's move on the next point. Okay kids, so types of motion, let's talk about the types of motion. Well, mainly there are three types of motion. Mainly there are three type of motion: oscillatory motion, transitional motion, and random motion. Yes, there are three type of motion. You can remember in a short form: RTO. Yes, RTO. Okay. um, R for random motion, and T for transitional motion, O for oscillatory motion. So oscillatory, what is the spelling of random motion? RANDOM. What is the spelling of transitional motion? TRANSITSIATIONL. Transitional. TRANSIATIONL. Transitional motion. And oscillatory motion. OSCILLATORY. Oscillatory motion. Yes. OSCILLATORY. Oscillatory motion. So these three type of motion: random motion, transitional motion, and oscillatory motion. Okay. Well, there is one more motion: rotational motion. Okay. So we can say that we can also say that there are four type of motion. Okay, if we include rotational motion. So uh, basically we study only three type of motion, but rotational motion um, is also included, so we can say that there are four type of motion. Okay, so RTO: R for random motion, R for rotational motion, T for transitional motion, O for oscillatory motion. And transitional motion can be categorized into three category. Yes, there are three type of transitional motion. There are three type of transitional motion: rectilinear motion, curvilinear motion, and circular motion. Yes, rectilinear motion. What is the spelling of rectilinear? RECTILINEAR. Curvilinear, CURVI linear, LINER. And circular CIRCULAR. Okay, so these three type of motion of transitional motion. Okay, RCC you can remember in shortcut RCC. R for rectilinear, C for curvilinear, C for circular. Yes, okay. So RTO, RCC. RTO are main type of motion, R for rotational motion, R for random motion, T for transitional motion, O for oscillatory motion. RCC are the type of transitional motion, R for rectilinear motion, C for curvilinear motion, C for circular motion. I hope you understood. Now let's discuss about the motion. Let's move on the next point. Okay, kids. So motion. So what is motion? As you can see on your screen, I have written the definition. So motion is the change in position of an object with respect to time. Yes, motion is actually change in position of an object with respect to time. Change in position means motion is actually change going from one place to another place with respect to reference point. Yes. So suppose I am walking. Suppose I am walking. If I walk at, at the same place at one position, will it be motion? No, it will, can you cannot call it a motion, because in motion position should be changed. If you are walking at one place, and then it's not motion. Motion means position should be changed, means one place to another place. So if you walk from Kana Kingdom school to Didwana, then it is called motion, because when you will walk from Kana Kingdom school to Didwana, it will take time. Maybe it will take 10 minutes. So it is respect to the time. So motion is the change in position of an object with respect to time, or you can say with respect to origin point. Always should be a starting point. Okay, reference point. So, motion can be described in terms of distance moved or displacement. Yes, we can describe the motion in terms of distance or in terms of displacement. So, because when you move, when you are in motion, when you are in motion, you travel some distance. Or if you are going in a direction, if you are going in a direction, it means you are doing displacement also. So what is the difference between distance and displacement? Yes, let's study. But before we study about distance and displacement, let me tell you one more thing. What is the meaning of scalar quantity and vector quantity? Yes, I have not written it, but I am telling you. Sorry, I have a little bit problem. Scalar quantity. So what is scalar quantity? Scalar quantity is any quantity which has magnitude but no direction, and vector quantity is that quantity which has not only magnitude but also direction. So which are the scalar quantity? Yes, distance is a scalar quantity. Okay, and speed is also a scalar quantity. Mass is also mass, you can say MASS. It is also a scalar quantity. So they have magnitude. Yes, speed have a magnitude, mass have a magnitude. Magnitude means what? Magnitude means numerical value. Magnitude means numerical. Mass do not have any direction. Yes, but if we talk about the vector quantity have all the vector quantities have magnitude as well as direction. Yes, so scalar quantities are those quantity which shows the magnitude. Yes, but vector quantity shows both magnitude along with direction. For example, displacement. Whenever you talk about displacement, you always direction is always included. Okay, and velocity is also a vector quantity. And I hope you understood. Okay, Weight is also weight, weight is also vector quantity. Okay, now let's study about the distance moved. Distance, what is distance? What is the distance? What distance is the length of the path. Distance is the length of the path. Yes, so you can say also that distance is actually the length between 2 points. Yes, suppose these are my two hand, so there must be a distance between two hand, maybe 10 centimeter or 15 centimeter. So distance is the total length of the path. Okay, means distance is the difference between 2 point. Yes, 2 point length of between 2 point. So I have 2 point, one point is my left hand, one point is my right hand. So these are 2 points. Well, what is the unit of distance? The unit of distance is meter. Yes, the unit of distance is meter. Well, there are many small units, centimeter, bigger unit kilometer, but actually SI unit that we use to measure the distance is always meter. Yes, now displacement. What is the displacement? Displacement is the shortest path traveled by any object from, okay, traveled by any object from initial position to final position. From initial position to final position. Okay, it is shortest path. Suppose if you start walking from um, Kana Kingdom and you go to your house, what is the distance between Kana Kingdom and your house? Maybe 2 kilometer. Okay, suppose if you start walking from Kana Kingdom school and reach to your house um, in 10 minutes, and it takes 2 kilometers distance. Okay, so if I say, if I tell you a shortcut, if I tell you a shortcut to reach to your house from Kana Kingdom, you will reach within 1 kilometer. That is the shortest path. This is known as displacement. Yes, so if you know any shortcut, then you will reach directly. Means you are going from initial position to your final position directly. Yes, so displacement is the shortest path traveled from initial position to final position. For example, as you can see, if a body start moving in a straight line from the origin O and moves through C and B and reaches A, then moves back and reaches C through B, then what will be the distance? What will be the distance? So suppose, as you can see in the picture, you start walking from O position. O is the origin where you are standing. So that starting, and you go from O to C, then C to B, then B to A, then again A to C, you come to A to C. Okay, so now you are at O to C. Okay, you are at the C point. First of all, you start walking from O point. You went O to A. Yes, you went O to A. Yes, you went O to A. Am I right? And then you start again walking from A point to you come to C point. Okay, so what is the distance? So you went O to A. O to A distance is 60 kilometer. Yes, and A to C, what distance? A to C, C point is actually at 25 kilometer, A point is at 60 kilometer. So you will minus 60 minus 25, 35. 60 minus 25 is equal to 35. So you will add 60 plus 35. Your complete distance is 95 kilometer. Because at last you reach to C point. Yes, you reached to C point. If I tell you go directly shortest path, then what will be the shortest path? The shortest path to reach to C point is from O to C, and O to C is the length is 25 kilometer. Yes, You no need to go to A to B, then B to C. Yes. So displacement is the shortest path. So here we will get the value 25 kilometer. Yes. Am I right? So in this way you can get the value. So distance is the total path from initial, from one point to between 2 points. Okay. So total path, actual length of the path, okay, traveled by a body or traveled by an object. But displacement is the shortest path traveled by an object or a body from initial position to the final position. Okay. I hope you understood. Just remember, displacement means direct path, shortcut. Yes, shortcut to go from one position to another position. Okay. I hope you understood. Now let's talk about type of motion. Let's move on the next point. Okay, let's study about the types of motion. There are mainly two type of motion: uniform motion and non-uniform motion. Yes, there are two type of motion: uniform motion and non-uniform motion. And what is uniform motion? Uniform motion is that motion in which speed does not change. Means speed remains constant. Speed always remains same. But non-uniform motion is that motion in which speed changes. Means speed does not remain constant. Yes, when the speed is not same, it means actually it is velocity. Velocity is, we can write in the place of when speed is not change, speed is changing, means here we will write the word velocity. Okay. So in uniform motion speed is same, in non-uniform motion speed is not same. Okay. Okay, uniform motion, as you can see the definition, I have written two more definition. As you can see, if a body travels equal distance in equal interval of time, it is said to be in a uniform motion. Yes. What is uniform motion? If an object or a body travel equal distance in equal interval of time, then it is said to be a uniform motion. But what is non-uniform motion? What is non-uniform motion? Yes. Non-uniform motion is a motion in which if a body travels unequal distance in equal interval of time, it is said to be a non-uniform motion. Yes. So what is uniform motion? If equal distance traveled in equal interval of time, it is known as uniform motion, and equal distance traveled in unequal interval of time, then it is known as non-uniform motion. Listen the again word: equal distance traveled in unequal interval of time, or unequal distance traveled in equal interval of time, or unequal distance traveled in unequal interval of time. There are three definition of non-uniform motion. There are three definition of non-uniform motion. First definition: equal distance traveled in unequal interval of time. Now, unequal distance traveled in equal interval of time. Now, third definition: unequal distance traveled in unequal interval of time is known as non-uniform motion. Okay, but in uniform motion, distance and time traveling should be same. Okay, so the graph for uniform motion will always be straight line graph. Yes, the graph for uniform motion is always straight line graph, but the graph for non-uniform motion cannot be straight line graph. Okay. Okay, kids. Now let's study about the speed. What is speed? So speed is actually the, we can say, the distance traveled by the body in unit time, in fixed time. Okay, speed is the distance traveled by an object in a unit time is known as speed. So what is the formula of speed? What is the formula of speed? Speed is equal to distance upon time. Yes. So speed is equal to distance upon time. This is the formula of speed. Yes, as you can see, speed is equal to distance upon time. And suppose if a body is traveling, and the distance is s in t time, then its speed will be v. Yes, so we can also write v is equal to s upon t. We also denote by the letters. Distance is denoted by s, distance is denoted by small s, time is denoted by small t, speed is denoted by small v. So we can also write v is equal to s upon t. V is equal to s upon t. V means speed, s means distance, t means time. Okay, v is equal to s upon t. And what is the SI unit of what is the unit of speed? What is the SI unit of speed? Well, you know that what is the unit of distance? What is the unit of distance? What is the unit of distance? Yes, the unit of distance is meter. The unit of distance is meter. And what is the unit of time? Yes, the unit of time is second. So we know that speed is equal to distance upon time. Distance means meter, time means second. So meter upon second, meter per second. So the SI unit of speed is meter per second, or you can write meter second inverse. Okay. Since speed has only magnitude, it is a scalar quantity. Yes, because it shows the magnitude. So it is the scalar quantity. Because whenever we talk about the vector quantity, we also show the direction. When you drive the bike, you always say that today I am driving the bike with 90 kilometer per hour speed. Today I am driving the bike with 50 kilometer per hour speed. You never say like this. Today I am driving the bike 90 kilometer per hour speed in south direction. Do you say like this? No, we do not say. I am driving the bike. I am riding the bicycle with 30 kilometer per hour in east west direction. Do you say like this? No, you don't say. So speed is a scalar quantity because it doesn't show the direction. Yes, I hope you understood. Now let's talk about the average speed. Yes, what is average speed? So the average speed is defined as the total distance traveled uh, to time taken, total time taken. So average speed is the ratio of total distance traveled to the total time taken. Yes, so average speed actually the ratio of total distance traveled upon total time taken. So suppose you have given the value in kilometer or meter of distance. Okay, and you have given time, then you can add the whole distance and add time, total time, then divide them, you will get average speed. So the formula for average speed is total distance traveled upon total time taken, and the formula of speed is distance upon time. Yes, I hope you understood. Now let's move on the next point. Okay, it's time to ask question from you. So I have written four question. Question number one. Write the difference between scalar quantity and vector quantity. Yes, scalar quantity and vector quantity. So what is a scalar quantity? Scalar quantity is that quantity which has the magnitude only but no direction, like mass and speed and distance. Yes, they are scalar quantity. And what is vector quantity? Vector quantity is that quantity which has not only magnitude but also direction. Yes, so we can say that one more difference is scalar quantity can be positive but vector quantity cannot be. Scalar quantity is positive but vector quantity can be positive, negative, both. Okay, I hope you understood. And next question, question number two. What is speed? Right, it's SI unit. Yes, speed. You know that speed is actually the distance traveled by a body in per unit time. Yes, speed is defined as the total speed is defined as the distance traveled by the body. Speed is defined as the distance traveled by the body. Yes, speed is defined as the distance traveled by body in per unit time or in a unit time. We know that the SI unit of speed is meter per second. Yes, what is the SI unit? Meter per second. Yes, what is the SI unit of speed? Meter per second. And the formula for speed is distance upon time. Distance upon time. And if we talk about the average speed is actually the um, mm, total distance traveled and total time taken. It is the ratio of total distance traveled to the total time taken. And next question, question number 3. Question number 3 is define distance and displacement. Yes, what is distance? What is displacement? You know, distance is actually the length of the path. Yes, total length of the path. Okay, distance is total length of the path. Distance is a scalar quantity. Yes, and what is the SI unit of distance? Meter. Yes, so it is the length between 2 points. Okay, the total length of the path traveled by a body. And what is displacement? What is displacement? Displacement is the shortest length of the path from initial position to final position. Yes, displacement is the shortest length of the path from initial position to the final position. Now, question number 4. So, question number 4, as you can see on your screen, define motion. What is uniform and non-uniform motion? Yes, what is motion? Well, we know that motion is change in position of an object with respect to time. Yes, what is motion? Motion is actually change in position of an object with respect to time. Okay, or you can say motion is change in position from one place to another with respect to origin point. Okay, means reference point. Now let's talk about the uniform motion and non-uniform motion. What is uniform motion? Uniform motion is that motion in which speed remains constant. Yes, it means speed does not change. So we know that what is speed? Speed is distance upon time. So neither distance will change nor time will change. Means equal distance and equal time. So we can also say that if a body travels equal distance in equal interval of time, it is said to be uniform motion. Yes, if a body travels equal distance in equal interval of time is known as uniform motion. Now, what is uniform? What is non-uniform motion? Well, non-uniform motion is that motion in which speed changes. Speed never remains constant. Means speed is changing. Means it's a velocity. So speed is changing. We know that speed is distance upon time. So distance will change or time will change. Either time will change or distance will change, or maybe possible both will change. So we can say if a body travels an equal distance in equal interval of time, it is said to be in a uniform motion, non-uniform motion. Or one more definition, if a body travels equal distance and in unequal interval of time, it is said to be in a non-uniform motion. Or one more definition, if a body travels unequal distance in unequal interval of time, it is said to be in a non-uniform motion. So I hope you understood. Now in the next class we will study about velocity and acceleration, and we will also study a graph which is actually a distance time graph. Yes, we will study distance time graph for non uniform motion. Okay, till then